To all the digital clock fans, we have a project. Here we have an ESE-182 electronics digital clock. An ESE-182DPW. It is boasting the Panaplex displays. I think they're the Sperry SP101, and some of them look to have a few little display issues. I think the three on the right are the worst. They're very subtle on that. I think we're going to leave that one alone. We're going to dive in and see if we can clean this whole baby up. So with a few screws pulled, top cover removed, we have the untouched dust of the past. And we look around on the circuit board. I kind of half expected to see CMOS technology in here, but I'm beginning to think I see 7492, 7490 under this wire. $74.90. Yeah, okay. We have 7400 series logic in this. I didn't expect that, but this is typical of ESE back in the day. CMOS was a little later. I'm seeing 1977 date codes on at least 1, 2, 75 date codes on some others, 77. Yeah, I'm thinking that's 75. I don't know if I could read this date code correctly. 7514. So, for argument's sake, let's say 1977. And looking a little closer at this board in its entirety, it looks like this lower edge has been chopped. And I'm starting to think I recognize this as the same board used in some of the other clocks that I've experienced. The Numatron tube clock, the ESE-112, an ES-10 I believe. Yeah, it's just their board hacked down. And they take the BCD counts instead of feeding to what would be other driver ICs on the board. That section's cut off. The BCD counts are taken from the counting chain and wired up into the display board, which is still fastened to the front panel. The display board has 6 drivers on it for the 6 SP101 Panaplex displays, and they are most likely the 7-segment high voltage BCD decoders. And let's pull that board off, as we have to anyway, to be able to unsolder and change out 3 of the horrible looking displays on the right side. 2 screws removed, angle brackets in the bottom panel to the display board. And this can be lifted out, and we'll tilt it up. And here we see darkened displays, pretty much cooked out beyond their lifetime here. So either it's hours and hours of use, or I am not sure about these drivers, but these drivers have a program resistor to be able to set the current limit of this display. And I wonder if failure could occur there, unless it was just one new display put in here at some point in its life, and these others, obviously, these have a little burn in. Not as bad as the three on the right. The decoder driver used in this is the DS-8880N high voltage BCD to 7 segment decoder. The other interesting thing in this clock, it's old. The clock circuit comes right up as it's not attached anymore. These plastic standoffs have kind of ended up in disintegrated amounts scattered around the bottom of the cabinet here. So we may have to fit some better standoffs in here upon reassembly. So that's the scope of the project here. Do this one and maybe that one. And we gotta clean all this up. I'll do a little of that now. Lots of little flakes of solder. You gotta watch, make sure they don't end up in bad places. A little denatured alcohol. Almost new again. flakes of solder here, almost bridging that junction. Let's just clean that off. This seems to grab it pretty good. And then so on and so forth. These are in the hour section. We're going to hang on to these for something in the future. The other ones are pretty toasted. And we left the one good clear one in there. This is all cleaned up. Clean these up a little bit more. Pre-test the replacements. Make sure they're working well. Solder them in. The display will be done. High voltage supply, 170 volts, through a 68k ohm resistor for these SP101 displays. There's 3 pins on the bottom, 2 are anodes, go opposite the evacuation tube, I believe. And there's 2 pins per segment, and they're kind of shaped like an 8 on the back. Segment looks good. Segment looks good. Segment looks good. Alright, just have to do that 6 times. No, 5 times. Excellent. We already have one in there, remember? Yes. Evacuation tube hits the board, so that sets the depth of this corner. Then you just have to float it in the holes and solder it in place carefully and slowly. Start with this corner. segments. The rest of it doesn't need to be soldered. The display is much nicer. There's something going on now. Fast set. 7, 6, 7, whatever it is. Some invalid counts. The hours section is it disrupted something. Well, flipping wires back and forth. I definitely broke the power wires off the board. I didn't flip it back and forth that much, but the high voltage wires both broke off, so they're soldered back on. So something else must be loose. We'll be looking into that. But at least it's grossly working, and the display is much more pleasant and even. There was this wire already broke off. It goes to some additional functions in the back I'm not sure of, but stuff like that we're going to be looking for. So we broke away for dinner, and sometimes getting away from a project, you start thinking, when you run into a problem, what could it be? That looks like a decoding problem. Well, what did I do? I moved a few things around, really. Look at that. We got a loose connection. And now it looks like it counts properly. So I guess a couple solder joints on this BCD input to the ones of hours position will fix that problem. And then this baby's ready for a deep cleaning on the inside, and we can button it back up. It's never that easy. So I cycled the time, fast setting, and I counted. We have decoding issues going on, and I'm not sure where the problem lies. It's not a loose connection here. I soldered the ends of those 4 bits coming into this decoder driver, and the problem is solid now. It's not intermittent anymore. So as I was saying, I cycled the time, and this should be a 1 currently, and the B input is floating somewhere in between 0 and 3.5 volts, so 3.5 volts being high. So if I take ground and apply it to the B input, it goes to 1 like it should. The problem is somewhere between the 7490 and this decoder driver. Unless it is the 7490, that's bad. The thing that's steering me away from the 7490 is that I thought I had a loose connection up here. And like I said, I hit these with the soldering iron, and I have solid continuity down to the control board, so it's not a wiring issue. It's something on the main board, I'm thinking. Maybe a loose connection was down there. Cycling. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. That should be a 1. $74.90. pin B. That's going to be 1, 2 over on the side closest to you guys. What I'm going to do is look for continuity between the decoder driver, that's B here, and then down to the 7490. I'm not getting any continuity there. If I come to where this wire harness hits the board, I have continuity, if you can hear the beep. So somewhere between the board and this pin, we lost continuity just by moving things around. 1977 to now, jostled around, and that's on the board. Maybe it's a solder joint. Let's see if we can get this thing flipped over, and let's see if we can get continuity. There's a trace on the underside of the board, a big solder blob, but I can't see if the wire is actually into the solder blob. Is it possible that hope you guys saw that. It's in the board, but it's not soldered in. Okay, that's our problem. Bad solder joint. I was able to pull that right out. It's not soldered in. So we'll solder that wire back in, and the clock should then work properly. Okay, big test. 12, 1, 2, 4, 5. Beautiful. It's working. So how I discovered it was the B line coming into this decoder is I put a voltmeter between ground and the 4 lines coming in. And you should either be very close to 0 or high. High seems to be about 3.6, 3.7 volts here. I had a 1.6 volt reading on the B line, which was in the middle. So I took that as a floating input. It turns out it was a floating input, and it was found on the main board. So yeah. So when I wiggled the wire before, it wasn't up here. The problem was down on the other end of that wire on the main board. That's it. Put it back together, a little cleaning, and it's done.